the x value represents the amount of time it took the ball to reach its max height. What does the y value mean? The y value is the max height the ball attained. If the, this is a great question. I love this question. I hope there's one on the test like that. If a receiving player catches the ball at a height of 6 feet, when will he catch the ball? All right, well, let's go back up to our graph and take a look. Okay, so, come on, pen. So, a height of 6 feet. So, here's 6 feet. And let's assume he catches the ball right there at 6 feet. So, the graph looks like this. Oh, that is a nice tracing job. So, the ball is launched. 1 second goes by. 2 seconds go by. And boom, stops right here. This is where he catches the ball right here at 2.2 seconds. How do I know that's a 0.2 and not a 0.1? Because look, 2.0, 2.2, 2.4, 2.6, 2.8, 3.0. So each one of these little tick marks represents 2/10 of a second, 1/5 of a second. So if he's 6 feet tall, he'll catch the ball at 2.2 seconds. .2 seconds. Describe what happens to the ball at between 3.6 and 3.8 seconds. Okay, let's go back up to our graph. 3.6, 3.8, 3.24, 3.6. Wait, dang it, why is my memory so bad? 3.6, 3.8. 3.6, 3.8. I mean, it's hitting the ball. In this area, it's hitting the ground. This is when it comes into contact with the ground. The ball hits the ground. The ruling on the field is incomplete. Incomplete. What the? Oh, it looks like this page is identical to the previous page. That's funny. Alright, well, I guess that means we can skip it. Oh, I really need to look at this stuff before I begin to talk about it. Dun, 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 dun. Number 17, which shows the functions, which option shows the functions correctly listed in order from widest to narrowest? Okay, so remember, widest, a nice wide parabola, means we'll have a very small fraction. So, so we'll have a fraction. And then narrowest, oh my gosh, a bird almost flew into my room here. And narrowest means we'll have a whole number that's larger than 1. So what you need to keep in mind here is that this number is going to be greater. The absolute value of this number is going to be greater than this number. So remember, just ignore the sign in front of the number. So widest to narrowest. So we're going to need, okay, so here's some fractions here. 1/7, 3/4, 5. Okay, that looks like a good one. 3/4. So we can say 1/7 is less than 3/4, which is less than 5, which is less than 7. 3/4 is not less than 1/7, 1/7 is less than 5, which is less than 7. So this B is the only option here. This one is wrong because that would mean it's starting at the narrowest. Narrow, not marrow, narrow. And this is wrong because it's also starting at the narrowest. This is the right one because negative 1/7 is smaller than 3/4. I'm sorry, not negative, just 1/7 is smaller than 3/4, which is smaller than 5, which is smaller than 7. Wow, we're almost done. This is a short review. 18, which equation will produce the widest parabola? Parabola when graphed. So the widest one, remember, has the fraction, so 0.2 will, because 0.2 is smaller than 0.6, which is smaller than 6, well, which is smaller than 2, and 2 is smaller than 6. If you don't believe me, you can just ask your calculator here. Let's see if we can do this. Let's graph those. Let's graph these options here. Let's see what it looks like. Clear. Okay, so I'll put in 2x squared. So there's our first one, 2x squared. I'll make that the normal one. Then we'll type negative 6x squared. And I will make this one a bold line. Let's do negative 0.6 squared. So negative 0.6x squared. And I'll make this line, I'll make it a dotted line. There we go. And 0.2x squared. And I'll make this one a regular line also. So let's see what those graph. Oops. Can't tell anything from there. So we'll go zoom 6 to zoom standard. So there's 2x squared, negative 6x squared, 0.6x squared, and then 0.2. Look how wide that one is. And if you're looking at this graphing screen, you're going, oh my goodness, I don't know which graph is which, Mr. Russell, I don't know what's going on. You can press trace, and by pressing the up key, the up arrow, this guy right here, you can hop from graph to graph, and then just see what graph your cursor is on. So we see that this widest one, when we press the up arrow here, it jumps over to 0.2x squared. If we press up again, our cursor is on that one. If we press up again, our cursor is on this narrow one. If we press up again, it's on this one. And finally, when we press up, it ends up on this wide one. So that's how we can use our calculator to take a look at 18. All right, let's finish 19 and 20 here. If the graph of the function x squared plus 4, how would the graph of the function x squared plus 4 be affected if the function were changed to x squared plus 1? Well, the only thing that's changing here are our intercepts here. This would be shifted 3 units down because we had to subtract 3 units on the y-axis to get to there. Which quadratic function has a vertex below the origin and opens upward? Oh, great question. You know what was lacking on this test review is domain and range. Interesting. So opens upward means our parabola will be opening upward like this. So it's going to have to be positive. So we know that those aren't it. So it's going to be one of these two here. And what quadratic function has a vertex below the origin? So we know it's going to need to have a negative shift. So D is our answer. Boy, well that does it for the test review. That was pretty quick. It is interesting that there were no domain and range questions on this review, but we practiced those ad nauseam. That's 6 years of Latin coming out right there. We practiced these ad nauseam in class, so hopefully you're prepared for those. But anyway, this is going to be a pretty good test. I haven't seen it yet, but I will give you more information as the test time arises. Remember, practice this review. Practice it over and over and over again. Practice finding those roots if you have a calculator at home.